everyone, and welcome back to our course. In this lecture, we're going to compare regression techniques for cryptocurrency or stock machine learning. So join me at Google Colab where we can build and run our project. We're going to get our stock data from Yahoo Finance. So go to finance.yahoo.com and search up the stock that you want. Go to historical data and select your time period, and then you can download your stock data. You can also find a CSV file of this data at the end of this section in the source files. Once you have your data, go into Colab and upload the CSV file into your files. You can also upload the CSV file to Google Colab for more permanent storage. All right, now let's load our data. So I'm going to make a reference to the data path using ETH-USD, the name of the file, .csv. Then I'm going to import the pandas library and use pandas.readcsv, passing in my data path. We can store the results as our data, and then we can inspect the data with the head function. All right, so here we have our stock data. We can also automatically set our index column to equal the date. We can infer the date time format and set parse dates to true. If you rerun this code cell, your index column will now be your date. Next, we're going to define our X and Y data for our regression technique. For regression, your prediction that you're trying to get should be in the form of a number that can be represented on a number scale. So our X data will be our data at the open column, and our Y data will be the data at the close column, which means we're going to use the X column to predict the Y column. You can also select multiple columns or create new columns and use other features to predict your Y. All right, next up, we are going to split our data for training versus testing. So we're going to import from scikit-learn.model selection the function train-test-split, and we're going to call the function train-test-split on our X and Y data. Our test size will be 20% of the data. We can also pass in a random state optionally. The result of this will be our training data for X, our testing data for X, our training data for Y, and our testing data for Y. And there we have that data. We can run the code cell and then we can inspect xtrain as well as inspect ytrain. So we can print out the values and then run the code cells. And you should see they should have the same number of rows. And X contains open, Y contains close. And the date ranges should also match up. Xtrain should match up with Ytrain, and Xtest should match up with Ytest. Okay, now that we have our data, let's create some models. So join me coming up in the next lecture where we're going to build different models and then we can compare the results. Hello everyone, and welcome back to our project of comparing regression models for cryptocurrency machine learning. Previously, we loaded our data, and in this lecture, we're going to use the data and build regression models to predict ETH price. So join me back in your Colab project. We're going to start with linear regression. For that, we're going to import from scikit-learn.linear-model the class linear regression. This has the setup for our model for us. So we'll call this our linear model, and we'll instantiate a linear regression model. Then we'll take the linear model and fit it to our training data. That is the training process, and then we can get our predictions using our linear model.predict and feeding it the X test. Then we can evaluate the results with scikit-learn metrics and using the R2 score. And we can save our linear score by calling R2 score on our Y test, which is the actual Y, versus our predictions. Right, then we can print out our linear score. Right, so that is the score for prediction using the linear regression model. Now, what if we want to try out other types? Well, we can try out other regression model types like polynomial regression and SVR, support vector regression, as well as decision tree regression and random forest regression. And we can apply different data science techniques as well, such as scaling. So we have linear regression. Let's add another code cell here. And from scikit-learn.preprocessing, I'm going to import polynomial features. Then I'm going to instantiate my polynomial with polynomial features, and I'm going to pass in my degree that I want to use for the polynomial, such as 4. You can try out different degrees and you'll get different results. Then we want to get our x data with the polynomial features applied. So for that, we take the polynomial and we use the function fit transform, and we're transforming our x training data. Then I'm going to instantiate another linear regressor, and I'll call this my model, and I'm going to instantiate the linear regression object. Then I'm going to take the model and fit it not with my x training data, but with my x polynomial data and my y training data. The results we can store using our model.predict function. Here we're going to pass in our polynomial and transform the x test, because if we transformed the x train, we should transform the x test. We can get our score using r2 underscore score, and this will be our polynomial score. So let's save this as our polynomial score and call r2 underscore score. We're passing in our y test and our predictions. Right, so then we can print out our polynomial score to see the results. Okay, so we get very similar result to a linear regression. All right, next up, what other technique should we try? Let's use scaling as well as support vector regression. So first, I'm going to scale our data. For that, I'm going to import from scikit-learn.preprocessing the standard scalar. Then I'm going to instantiate a scalar for my x and my y data. So I'm going to create an x scalar with a standard scalar and a y scalar for my standard scalar. All right, next I'm going to take my x training data and scale it. So for that, I take the x scalar and use the function fit transform and pass in my training data. Similarly, we can scale our y training data using the y scalar and calling fit transform on y train. All right, then we can inspect some of that data, such as the x train scaled. So you can see the range of the values are a lot different now because they've been scaled. All right, next up, we are going to use a support vector regression model. So for that, I'm going to import from scikit-learn.svm support vector machines the support vector regression model. I'm going to instantiate an SVR model using the SVR class, and let's use an RBF kernel. Then I'm going to take my SVR model and fit it to my x train scaled and my y train scaled. Then we can get our predictions using our y scalar dot inverse transform on our results. So to get our results, I'm going to create a variable and use my SVR underscore model and use its predict function, passing in the scaled test data. So I'm going to create x test scaled using my x scalar dot transform on the x test data. Then for the prediction, I pass in x test scaled. And that is what we can send here to that predict function. As well, I'm going to call reshape and pass in -1, 1. Then we can scale our results. And we can print out our predictions to see how it went. But to really get a score, we need to evaluate the model performance. So I'm going to get my SVR score using R2 score, passing in my y-test and my predictions. And then we can print out that variable value. So let's print out the SVR score. I'm going to run the code cell and we can see our score there. All right, coming up next, let's try some more models. We're going to use tree models coming up next, the decision tree and the random forest. So don't miss the next lecture. If you liked this video, then go to training.mammoethinteractive.com. We have tons more content on blockchain, web development, machine learning, and much more. We also have a membership for just $19 a month where you can get access to our 372 course bundle and counting.